In this video we want to talk about chamfer milling and corner radius milling in SURFCAM. In both cases the process is very similar to regular 2-axis contouring. I'm going to move up to NC, down to 2-axis, and down to chamfer mill. We chain the top of the profile that I want to chamfer, and click on Done, and our tool information shows up. If you look at the tool selection, you can see the typical configuration for chamfer milling. Here we have a 1/4 inch tip diameter with a 45-degree chamfer angle. I'm going to go to cut control, and the first thing I'll see is the chamfer width. This is how we measure chamfers in SURFCAM, the distance across the face. Here I have 100 thousandths, and that should be good for the part we're trying to chamfer. Right below that it says geometry is the. If the dot is in the corner, that means that the geometry you've created represents the corner of the chamfer. If you put the dot to the right, that means the geometry you've created represents the top edge of the chamfer. If you put the dot on the bottom, that means the geometry you've created represents the bottom edge of the chamfer. In this case, our geometry is at the corner, so I'm going to move the dot there. When SURFCAM calculates a depth for chamfering, it can do it in two ways. Here it says Z depth is at the geometry. That means that the Z depth will be calculated from the level of the geometry. If we want to offset that, we can just click Enter instead of at geometry and put an offset value here. I'm going to leave it at geometry for now. Tool Control Automatic means that the center of the chamfering tool will be on the edge of the chamfer. If we have to avoid a bottom surface or want to be above a top surface, we can adjust this by clicking on Above Top or Below Bottom. Cutter compensation is at regular offset. Direction is climb. We're going to leave no stock. I've got roughing selected with a maximum roughing depth of cut of 25 thousandths. It will take as many roughing passes as are necessary. We will also have a finishing depth of cut, which is 2.5 thousandths with 1 finish pass. Also at the bottom we have arc on all for every lead in and arc on all for every lead out. I'm going to click OK, and it's asking me for the side to contour. As usual, I'll click to the outside of the part and accept, and there's our chamfering operation. The next thing we'd like to do is to put a corner radius around the top edge of each pocket. To do that, I'm going to move up to NC, 2-axis, and then down to round mill. Once I've selected round mill, the next step is to chain the top edge of each pocket. Once I've selected all the pockets, click on Done, and we're back to tool information. If I look at the tool that I've selected, it has a tip diameter of 1/8 of an inch with a .062 radius on the corner. I'm going to go to cut control, and it's very similar to the chamfer mill which you just saw. Geometry is the corner in this case. Z depth is at the geometry. Cutter compensation offset. Climb milling. Stock to leave 0. Our maximum rough depth of cut is 50 thousandths, and we're going to have a 5 thousandths finish depth of cut with 1 finish pass. Arc on all for lead in, arc on all for lead out. Click OK, and the next question is select the side to contour. It doesn't matter what pocket I click in, all I have to do is click inside one of them. I click inside the pocket and accept, and there's our tool path. To see what the part looks like before the chamfer mill and corner radius mill are applied, I brought up a stock model of everything we've done up to this point. Next step is to simply click on Play, and our chamfer mill will begin, followed by the corner radius mill. If we zoom up after it's completed, you can see very clearly that we've chamfer milled the outside and have corner radius milled on the inside.